Why? Well, the reason is things were just taking too long to compile, too long to build, too long to think about. We want to program fast, and we want to program fun. And to make programming fun, you have to find ways to speed things up and make things work better. Not just the code itself, but the process of writing the code needs to be efficient. I'm going to talk about the Go programming language. We hope going open source on November 10th, which is in just a couple of weeks. So what is it? Well, I'm going to talk about all these pieces, but it is new, experimental, concurrent, garbage-collected systems language. Experimental because we don't believe this is the answer to everything, but we're playing and we think it's gotten to the point where it's time we should probably tell the world about it. It's concurrent because it's really important in the modern world. It's garbage collected because we have an opinion on that stuff, which I'll talk about quite a bit later. And it's a systems language in the sense that we intend it to be written to be used to write things like web servers and other system aspects like that. You have more control over some things than you have in other languages like, say, Java or Python. On the other hand, it's very good at things we found for things like front ends or just general programming. So although it's designed as a systems language, it has much broader use than just that. There's hello world, with the world being Japanese. You can see that it looks vaguely C-like, although there's some weirdnesses about it. Who's involved? Well, I'm giving the talk, but it's by no means my project. There's a bunch of people involved, and I want to make sure everyone's clear that some of the names are really important here.
Hi, I'm Ken Thompson, and I'm semi-retired. I worked on Go until the public release in November and a little after that, and now I'm having fun.
I'm Rob Pike. I work mostly on the libraries and help with documentation and basically make trouble.
I'm Robert Griesemer. I wrote part of GoDoc and GoFunt and worked a little bit on the spec.
He wrote the spec.
We've had a lot of help from a lot of people that this slide is too small to name. So I want to make it clear this is a collaborative effort, and the collaboration is growing. Why? Well, the reason is things were just taking too long to compile, too long to build, too long to think about. We want to program fast, and we want to program fun. And to make programming fun, you have to find ways to speed things up and make things work better. Not just the code itself, but the process of writing the code needs to be efficient. So what's happened? Programming used to be fun. What went wrong? Well, it's interesting. There's really been no new major systems language in at least 10 years, arguably longer. But in that decade, a lot has changed. The libraries have gotten bigger. Professional programming has, to a large extent, become a layering process. And so we layer more and more stuff on, and we also broaden out the base. And so the forest has become a thicket, and it's sometimes kind of hard to cut your way through it. Networking has pretty much taken over the world as the way to think about computing, but the languages don't really reflect that. And on a related note, multi-core CPUs are taking over too. It's getting harder to buy a high-end computer with only one processor in it. They tend to be multi-core, sometimes multi-chip multi-core. And again, the languages that we're using weren't really designed with that kind of stuff in mind. And it's also gotten, I think this is the thing that finally pushed us to try to do something, it's just gotten too slow to build software. The dependencies are uncontrolled, and the languages don't help you control them. So you tend to spend a lot of time maybe building things you don't even need, but you don't know it, can't prove it. The machines have also stopped getting faster. They've gotten more, but they haven't gotten faster. There are more processors, there are more of them, but the actual clock speed has hardly changed in the last few years. And yet the software gets bigger and bigger and bigger. And so somehow it feels like if we don't do something, then software construction is just going to become unbearably slow, and we need to think about the process of making it fast again. So why a new language? Why don't we just fix what we've got? Well, some of the problems are just fundamental to the way the languages are thinking, the way the type systems work, the way they're compiled, the way dependencies are managed. The languages themselves have these problems endemic in them, and to fix them, you have to rethink the language as itself. For instance, the libraries can't help you because adding anything to try to fix some of these problems is going in the wrong direction. There's too much already. We need to trim down, cut the fat, make things cleaner. Fixing it by adding software isn't going to do it. You have to sort of step aside and do something separate. And so we decided Robert, Ken, and I, a couple of years ago, that we need to start over. Just take a step away and think about the way programs are written and constructed and try to make a language that makes that process a lot easier. The sort of short version of the story is we want the efficiency of a statically compiled language, that means truly compiled language, but the ease of programming of a dynamic language. And I think we've come pretty close to achieving that. You can decide for yourself. Safety is critical. It's critical that the language be type safe and that it be memory safe. It's important that a program not be able to derive a bad address and just use it, that a program that compiles is type safe and memory safe. That's a critical part of making robust software. We want good support for concurrency. I'll talk a little bit about that. And we believe is the word, that the garbage collecting technology is advanced to the point where a garbage collected systems language actually makes a lot of sense. And also, we'd like the compilers to just run fast. Everyone knows this slide. And there's some truth to it. You know, you spend too much time waiting for compiles. So let me give you a compilation demo here.
Hi, my name is Russ Cox, and I'm a member of the Go team here at Google. Go has many interesting features, including built-in support for concurrency and a novel type system. But one of the main reasons that I enjoy programming in Go is that it's just plain fast. Most of my builds when I'm programming take well under a second. Let me show you. This is the math package with implementations of things like sine and cosine. And it's over 1,000 lines of Go and about 20 files. And if we build the whole package, it builds in about 200 milliseconds. We can also run the tests for the package, which rebuilds the package, including the test functions, and runs it. And that runs in well under a second. This is the whole Go package tree. There's about 120,000 lines of source code. And we're going to build the whole thing. And the package tree includes flags and regular expressions and the math library and formatting library, an RPC package, a full parser for the Go language, and many other packages. And there, it built in under 10 seconds, and that's just running on one machine, my laptop. When builds are that fast, I can get a lot done in a day. Go is a fast, fun, and productive language, and we hope you'll try it. There's more information and downloads available at golang.org.
So, the big picture, there's some fundamentals. We have a clean, concise syntax. We have a very lightweight type system. We got rid of implicit conversions because although they're convenient, they tend to cause a lot of confusion. So there's a runtime, there's a garbage collection, and then there's really strong support for concurrency. It's actually some of the best concurrency stuff I think that's out there. It's really good. And one of the reasons for needing garbage collection is that concurrent programming is very hard without garbage collection, because as you hand items around between these concurrent things, who owns the memory? Whose job is it to free it? So you need garbage collection to make concurrency work well. On the other hand, you need to get the garbage collection to work well, you need a language that makes garbage collection a feasible thing to do, which is another argument for doing a new language. So I don't have time to explain all of Go to you. It's a significant language. So to conclude, I think we have a really nice language. I'm having more fun programming than I've had in a long time because I feel like I'm getting work done, because I am getting work done. It's early yet. I think the language is going to evolve some more. There's things we know, but a lot of the basics are locked down pretty well. I think we're pretty comfortable with them. It's a very comfortable language to work in. It's very productive. You can write code really fast and have it work and be safe. There's tons of documentation. There's a specification, the complete spec of the language. There's a simple tutorial for beginners. There's a document called Effective Go, which is growing to sort of explain idioms and how you think about things in the language differently. There's some FAQs, and there's even other things than that. All the implementations are available as open source. And so if you want to try it, go get it. If you want to help, please do. There's tons of work to do to build it up to another level. We really are welcoming people to come in and talk to us about stuff, especially if they want to help us do some interesting library work or build new tools. There's plenty of room for things to happen. So that's our site, and that's our language. Thanks for listening.